you, Manpreet, for locating the issue and telling me how to solve it. So, why don't you share with all of us what was the issue, and I will show. Yeah, yeah,
Hello.
yeah. Hi, yes,
Hi, sir.
Manpreet. Yeah.
Sir,
So,
actually, there is a attribute, name attribute that is missing in the address column in the add customer.html file,
right, right,
through which we are getting the value in my sublet.
right, right, right. Okay, so I will also show that to. I'll show it over here. So I just did deploy. Over here, this name equal to address was missing, right? For the address part.
Yeah, right. It was missing there. Yes.
Okay, once that has been done, then now my this thing is going. The records are going. I was thinking there was some problem with the text area, but now the values in the data store is getting for the address also. So I've added it. Good, thank you. So let me see. Okay. Yeah, question. So web client ID is required to insert record in data store. Uh, when we are using the API method, the API requires you to have web client ID, which is mentioned on top. Okay. Um, just one second. I'll put your question and explain. Okay, so over here, when we have Maven-based applications, we are using the API method. When we are defining the APIs, here we are defining over here the client IDs as web client IDs, which is required for the API. So the question was, when do you require the web client ID? Do you need it for storing the data into database? But in case of persistent case, we never used the client ID because we are directly putting it onto the data store. We are not going through the API route. When we are going through the API route, then in this API definition, we need to give the clients who can be accessing the API. Does that answer the question? This web client ID is required then. Okay, so it's almost 12 o'clock and we have reached towards we have seen two ways of inserting records into the data store. One is using the API and one is using the this thing. The next part which is there is related to queries. However, before that, I want you to do a little practice, guided practice, a small exercise. I want to see whether it is possible or not. Let me just see whether it's possible or not. Okay. And you may fail, but we'll have to have it time bound. We can't do everything differently. So, one application I will ask you all to deploy and see. And that application also, I don't want you to code right now. Coding you can see later on. But I want to see whether at least you are able to deploy it. Can we do this small exercise? No output of customer in App Engine server. Yeah, okay, so Kati wants me to show the demo of output of customers in App Engine. So this was my add customer form. So I added, let's say, Raj, some number, and Delhi, and this is saved. And we can go back to see in the data store, refresh over here. So this value is now updated in the data store. And also notice that there is another ID field which is getting automatically generated, the customer ID. Okay. Okay, so, and also I think before I go ahead with the next part, 1 hour activity we will do, or maybe till 1 o'clock, so that at least you guys have some time to practice. 1 hour of practice, guided, but I will continue to talk to people over here. All of you, what you do is pick up the delete solution and try to deploy that on the App Engine. Delete activity, which is okay. No, you can take this from the nitstudent.com, the activity. So there is the solution for activity, not 8.5, 8.4 or 7.4, activity 7.4, 7.4, activity 7.4 is related to delete. Let me see. This one, so till the time I will talk to people over here, I want you guys to take either the steps and try to do it, or I mean take the input file and then try to build on it for the delete part, or take the solution and try to deploy this, so that you will get more confidence in deploying things on App Engine, and at least you would have deployed a database related application yourself. Okay, so I hope all of you have access to the system on which you are practicing. Is it the same system on which you are listening, or is it different? I'm sure it will be a different system. Somebody doesn't have a system available. Okay, let me ask, how many of you have that system available closely? Would have that system? Different system, right? Different system. But is that system available in like next room or next workstation or MR? Is that system available right now? I don't know. In MR. Okay, yeah, okay, fine. So, yeah, see, it's in the MR. Okay, no problem. Where did I go? Did I close it? No. See, this activity includes everything, most of the things. Delete one. It includes APIs. It includes data store. It also has, and those of you who finish this can try something to relate it to deploying some other activity, previous activity. This one I'm just experimenting right now. So how many of you have access to MR and system? Can you just say yes, no? At least I will know. How many, is it possible to do it right now? Yes? Can we do it right now? You have access to MR and we can do this quickly? I'm just experimenting first time. Yeah, go ahead.
Hello?
Yeah.
Hello?
Yes, ma'am. Yes.
Yes? Hello?
Yeah, go ahead.
Yes, sir, I have the system available in my MR.
Okay, great. So just 1 second. I'm just asking everybody else.
Okay.
So it is there.
Okay.
So there is the data files to faculty folder. In that, either you pick up the input file and follow the steps for the delete, or you take the solution and deploy it. And let's do this 1 hour. 1 o'clock we'll be back, and in that have food also. I mean, so that we can start with the next topic. Okay? How does that sound?
Definitely. It's okay. Good.
Yeah.
Yep. Right.
So, is this okay? Or how many of you don't have
Yes,
system? We'll talk. Yeah. So, how many of you don't have system available to try this out and are not able to reach Google App Engine? How many of you don't have access to the system through which you can access Google App Engine? Please let me know who all don't have system available, access to a system available right now, because slowly we have reached a stage where we are able to access Google App Engine. Yeah, so okay, you need to go to another room, a machine room, fine. I will take a break of 1 hour, and after 1 hour I want your links to show me that you have managed to upload something related to data store. If you fail with that option, maybe go to the insert, pick up the insert activity and deploy. At least one of the activity of data store you should deploy. So that, and see a record getting inserted, so that we can see the next part, which is queries. Okay. you will have more confidence once you can see the data and doing it. So we will take a 1 hour break, no problem now, and all of you can try this activity now. For people, before that you all go, just 1 minute. Just 1 minute. In the morning, I spoke to Sangeeta, Anuradha, Sapna, Karti, Nityan, Niyamat, Maninder, Trijita, Anjali, Jyoti, Anjana, Vishnu, Rajesh. Anybody else I logged in later and I have not spoken to. Rajesh voice was not there, and I think Trijita, the video was missing. Right? Anybody else who's there online now, can you send me a mail on Gmail your attendance so that I know who all are there for today? Please send me a mail today, right now, so that I know if I have missed out anybody. I can see only 12, but there are more logins. So let me see. Rest can go. I will just talk to people if there's somebody who's there. Rest of you can go and please do the MR. 1 hour. 1 o'clock we'll be back. I'm not doing anything new. I'm just going to talk to anybody who wants to talk. We'll just talk, communicate. If you want to talk to me, stay back and call me. Let me know who is there, and yeah, go, please go. If you have to go, please go. 1 o'clock be back, and if there is somebody who is, you can always get the data files from the shared location and download it and deploy it. So basic idea is to deploy it. Don't worry about debugging it right now. Even if it doesn't work, it gets deployed, try to see what is getting deployed. I want to build up some confidence in deployment. A little bit of hands-on will be required. So what about Bangalore? Bangalore is there now? Hello? Bangalore? Bangalore is there? Bangalore? Bangalore is not here. Some problem you told me. This one is there? Somebody is there. Pune Deccan. Hello, is there anybody from Pune? Right now nobody is from Pune, just empty slot. But Pathankot, Pathankot is not there, not working also. What is this? IDR RC road. What is this? Shahid Nagar. Hello? Shahid Nagar, you have opened the channel. Nobody is there. Good. Puna. Puna is just monitoring. Borivali. Let's 2, 3, 4, 5, 6. 16. At least 16 people should be there. Very good. Borivali has deployed Maven app. Very good. Yeah, Anjali, were you calling me or something? um, we can have a break sign now, I think. Hi, welcome back. I hope you had deployed something. Somebody tell me if they were able to deploy something. Were you able to deploy the delete application? Were you able to deploy it? Anybody had success? Hi, good afternoon. So anybody was able to do the exercise which I had given you? Please reply once you can reply, then we will proceed. Anybody who's there online and we have not spoken? So were you able to do this exercise? Yeah, or you not managed to do it and had some error? So let me know. What happened, CP? You were not able to do it? Some exception. One second, let me just talk to you. Yeah,
Hello?
yeah, Maninder. Some
So
error is coming.
there is some proxy related issues again. Yeah, there is a
Okay.
SSL error. Some proxy related error is coming. We'll try again and let you know by the evening.
Okay, no problem. Thank you. Okay,
Okay.
no
Thank
problem.
you.
Okay, very good. JDO is done. Good. Okay, this is the link. Okay, let me check it. Good. Okay, I've checked. Thank you. It's working. But Maven base didn't work, is it? I think we are waiting for other people to also. They must be having some of the other problems. That's why I think the practice has to happen after 5:30 when you have time. Um, but this was required because you should be comfortable with databases to go ahead with the queries part. Okay, now I don't know if you guys are back. Can you just raise hands and let me know if you're back? Anjali is back and Marinder is back. So hopefully people are back. Okay, Jyoti and Lee are back. So please raise your hands if you're back and let me know. Sapna is back. So Anjali and Jyoti, were you able to deploy something on the Google App Engine in this duration? And also Sapna from Ghatkupar, were you able to do something on data? Yeah, Jyoti was able to. No, from not complete. Okay. So what about Sapna? So were you able to get some errors? Hopefully you will learn from errors only. So it's okay if you were not able to do it completely. So Jyoti has done insertion, now doing the other part, which is initial, no problem. So the idea was to get your hands into the engine data store so that we know that data can finally be written on Google App Engine. So it was the purpose of this exercise was that you understand that we can write records into Google Data Store, and once you do it yourself, then you are more confident that yes, records can be added and updated and deleted in Google App Engine. And you may even get an error when you are doing this, so and you may learn from it some kind of error debugging. Okay, so it is important that you should have done some kind of a data insertion because it will give you more confidence in getting the hang of this Google App Engine. So who else is online? Who is like that? It's not executing, sir. Very good. Borivali saying it's not executing. Good. So Borivali, Vishnu. Talk to Vishnu. Yeah, Vishnu.
Hello.
Good morning. Yes, hi. Good afternoon.
Insert data. Good afternoon, sir.
What happened, Vishnu?
I'm trying to insert data, sir. Trying to insert data. I have created a reconnect and activity, but it is not executing properly.
You just deploy it. You have deployed it on App Engine.
I'm trying to. No, sir.
It's not
I'm
deployed.
not deployed. I'm just executing on local server.
Okay.
Local. But still it is getting error.
It is giving errors. No problem.
It is not executing. Okay, sir.
No problem. See, it's okay to have problems and it's not working at this stage because you learned how to debug it. So are you picked up the input file or the solution file? Or
I put input file.
okay. And it is not and
copied code.
And you copied the code, and then at the end it is not working. So it may be because of some reason that some step is missing or some step has not done completely. So maybe next time, just or right now maybe till the others are coming, Just pick up the solution and then try to deploy that.
Okay.
The solution file.
I will try. Yes, I will try.
Right. Later on, you can compare the solution with what you have done.
Yes.
Okay. So, okay, and for others also, I wanted to tell you that something similar to data files for faculty, we also made a folder called data files for students, and that also has got input files and task files and something similar to that for the exercises. The solution to the exercises are put in the data files for faculty. So we have not given the solutions like you have got it for faculty, for students, but we have put it as part of TRIM for data files for faculty. So you will find some solution files for exercises also in the lesson folders. Okay, so you will be able to use, in fact, as students should be able to try to assemble it, and if they fail, then you can share with them the solution, how they should actually be doing it. So Ankita. Hello, is this Ankita ID ASCII? Ankita is there? Ankita, is anybody on this channel? No, just blank channel. Okay. Is Bangalore online now? Can you hear me? Can you hear me? Hello? Is somebody there at Bangalore? Is somebody there at Bangalore? Is somebody in Bangalore? Is somebody in Bangalore? Eight, 9, 11. Uh, yeah. So, anybody else wants to share their experience? Were they able to? They were facing problem, unable to deploy, not working, unable to do it. Yeah, please share whether you are successfully or unsuccessfully able to do this deployment. Let me know your experience in deploying this application on delete query 2.7, 8.7.4. Anybody else who faced problems or had problem in deploying it? Did anybody else face? Did anybody try it out else? Try it out and had problems in connecting and uploading data store related activity, or any had success story. And also, please send me your emails for attendance. I have got only 3-4 mails today. So please send me your attendance mails so that I don't have to write anything. You have to just send me a mail at nitgae3.3@nit.com. So, uh, and if anybody else want to share the experience in the practical implementation, I try to convert. It is showing error or something. It is showing. It is not an App Engine project. Probably you should have probably import it as Maven project. No, I hope you are importing it in Eclipse Borivali as a Maven project. You know how to import through as a Maven project, different than a normal import. There is a Maven import Maven option, and if you do that, I think asking merge imported asking Maven project. Yeah, you have done that. Huh? So I wonder what your problem is. So Vishnu has some real problems. So solution is also not working. So maybe try some other insert, update, some other reconnect, because all of them are same variation of the same thing, and they are just working over here. And for others also, some of them they have been able to do it using the same files. I'm using the same files, so you should also be able to deploy it. I'm just talking about deployment right now. I'm not talking about nitty-gritty of function names and code. So I just want to be sure that you are able to deploy a data store related activity. That is my objective today or right now, that you have the capability of deploying a data store related application. One second. Okay, so today's task for people who are still stuck with data store applications is to be able to deploy at least one data store related application so that you can see more of Google App Engine and you can get a more hands-on experience on it, and that you can do it after the class in the evening, and you must spend some more time today to try it out so that you have more practical experience. Um, so let's continue then. I think people are back. Can we have a vote again? People are back. Yes, yes. Please click on plus or just let me know. Just enter your names so that I know if people are back. Difficult to get idea like this. Just enter your names, yeah. Mahendra, Jyoti, or yeah. Three or more people. Just enter your names. Anjali, 3, 1, 4, 5, 6, 7 are back. 8. One, 2, 3, 4, 5, 6, 7, 8. 8 are only back. I think some more are missing. Think Sangeeta is there. Anuradha. Bangalore is not mentioned anything. Sapna is there. Kathi is not there. Kathisian, Niyamat. People who are there in the morning are now disappeared. And Trijita, Anuradha is there, Bangalore. Very good. Kathisian is there, very good. Niyamat, Anjali, Jyoti, Anjana, Vishnu. Yeah, okay, Anjali, Jyoti. Vishnu disappeared. Oh, he's there. Rajesh. Okay. Rajesh is not there. Okay. So, I have got more attendance mails. Oh, okay. Just ignore this Vishnu Borivali. This is okay. This is ignore this error. Finish. It will be resolved later. We'll resolve it later. In the sense, we will not resolve this error. This is some dependencies which have gone outdated in form. So this is not a Maven, it will not impact a build. So ignore this message. Ignore this error. Ignore this error. Okay. Okay, great. Okay. Okay, so let's continue then. And I think the people who are missing. So the objective was to have you get more into hands-on to this. So okay. So we have to go ahead with this. So in this session we had done already. Now storing data in Google Data Store using JDO. Now we will try to attempt querying part. Query data from Google Data Store and try to understand what that means. Can I have a video played now? Can I have a video played now? Or maybe little? Name of the video is okay. This is now we are getting into depth of Google App Engine. So we are now into the looking at various nuts and bolts of this. So we are looking at how to query an index and look at transactions later on. So there is a file called data store query which is there in the videos under new folder. New folder, there is data store query indexes transactions. Yeah, just can you play? I'll ask you to stop in the middle. When I tell you to stop, you can stop. Okay. Just we'll do the first part queries. So just listen to this.
These are three topics I'll cover on this lesson. How does data store work on query? We'll discuss what the reason is behind these kinds of restrictions and how they're actually an essential technology to make it very scalable. The second topic will be the workarounds based to overcome those restrictions. Then lastly, I'd like to discuss about transactions in data store. Because data store is not a traditional database, the behavior of the transaction in the data store is completely different. There's an important concept called entity groups, which we'll spend some time on. So how does Datastore work on query? Bigtable doesn't support query. In ordinary traditional relational databases, you'll always be able to search on the value of a current column. But Bigtable doesn't allow you to do that. Bigtable can search only on a key. Then how does Datastore support a query? In Datastore, queries will be executed as an index scan of Bigtable. So this is the big difference between Datastore and traditional relational databases. Query is executed as an index scan. So think about a simple query like this. When it's trying to select all the person entities with conditions like height property must be less than 72, for this query, it will be executed as a range scan on Bigtable with an index table for height. Recall in the Datastore introduction session, there was a function called memscan. Bigtable can scan on a key, not on the values. So by having an index table on Bigtable like this, which has the property name and the property value in its key, then you can implement a query like this on Bigtable without reading the actual values. Actually, we're using values from the columns in the key of the index itself, so that we can search on the values by doing the index scan. This is how Datastore makes queries so scalable. Without any index table, most of the queries on Datastore are built through exception, or you have an error. But this is quite different than the traditional indexing in a traditional database. In relational databases, you might want to add an index just for the performance issue. If you don't have any performance issues, like if you are just having 100 rows in a table, then you don't have to put any index on the traditional database table. You can still run a query without having any index. But in Datastore, you cannot execute almost any query on Datastore without an index table. This is not a restriction. This is a key technology. It's why Datastore query can be practically limitless. If you are using a traditional database, there's a certain scalability limit on the query. But on Datastore, you can just run a shard among the multiple physical servers. But you don't have to care about that by yourself. All the underlying layers, like Datastore and Bigtable layers, are taking care of all that, sharding all the data into multiple physical servers, or dispatching the queries onto your multiple physical servers. That's not achievable in a relational database. The most important point is that the index scan makes query performance for the size of your results, not with the data set. So no matter how many entries you have, it doesn't affect your performance of your query. Your query performance will be affected only by the size of the result set. If you are trying to get millions of records as a result set, you will decrease your query performance. The size of the whole data set won't affect your query performance. But how does this support various queries just by index scans? As you saw, the index scan mechanism is so simple. So you might wonder how it can support complex query conditions like where or order by clauses. The answer is various kinds of index we have on Datastore. One is the single property index. Single property index will be working for queries with a simple sorting or filtering, just like this. So here's a sample query with very simple conditions like name property equals John. If you ran a query like this query will be converted into an index scan on the single property index for name property. For every single property or entity, there will be a single property index automatically created for you. You don't have to define explicitly to build that index. Every single property index will be automatically created for all properties. So if your entity has a property called name, then the single property index will be created automatically. And if you execute a query like this, then it'll be converted and executed as a range scan on this index table, or index scan for a key, for a parent name and John. This is actually a key of the index table. So these are the keys of the index table, and there should be a value, which is the key for another table. This is how you can write the simple query on Datastore in Python. Because you are not directly handling your big table, you can just use the simple query language like this. This is another example of the queries that is executed to be a single property index, which has the unique quality of filtering, like the greater than, equals, or if-then operators, and also sorting using the order by clause on a single property. We're still handling filtering or sorting on just one property, so that those queries can be handled by the single property index. If you are handling just one property in a query, then these queries can be executed as a range scan on a single property index scan. In this case, it's trying to find a name which starts with B, so it will be converted to a range scan, from Bob to Brad, for example. And there's something else you should notice, that single property index actually uses two index tables. One is an ascending table, and another is a descending table. So every single property, there will be two index tables automatically created. So this single property index can support queries like this, like the equality filters. At this point, for this particular query, you don't have to have a composite index that will be discussed later, because DataStore will merge the results of the queries for each properties into one automatically. So DataStore will execute a query for the first name equals Bob, and then execute a query for last name equals Jameson, then merge the result into one. Also, inequality filters or not equals attribute can be executed by the single property index like this. And not equal to filter like last name not equal to Bob will be converted internally as a query like this. This should be or actually. First name Bob. This will also be handled as a single property index too. Let's discuss the more complex query. For more complex queries that would involve more than one property, you would need to create an index code or composite index. This is also known as a custom index. This is an example of the query for composite index. If you are using an inequality filter on one property and combining it with the inequality filter on another property, then you would need to build your composite index for that. And a composite index has a logical value, has values for logical properties like kind name, and values for the last name, and values for the first name, so that this data store can convert this kind of complex query into a simple index scan. The combination can be very complex, with lots of tables being created for that composite index. You, the developer, have to explicitly define that by your configuration file. This is an example of a query for a composite index. In Java, you can specify that in the files called datastore index or in the index.yaml file. In Python, you can just use your index.yaml file. Or you can write the definitions of the composite index like this. You can specify the kind name and the rest of the properties with the property name and the directions you want to have. By specifying this and deploying this application onto the cloud, DataStore will start building the composite index for you. Composite indexes can support queries like this, as we just saw in this example. The queries with the inequality filters and equality filters on other properties, or the queries with logical sort orders. This will be a very popular use case for the composite index. So let's move on to the workaround part. How can we make DataStore query operate almost as flexibly as a relational database query? We cannot say DataStore will be super flexible just like an RDB, because a single DataStore query will have to be super scalable. We'll have to have certain restrictions. For the App Engine developer, it's very important to understand those restrictions and workarounds before you start designing your data model. Like the restrictions, inequality filters and sorting needs an index. Inequality filters like less than or greater than are only applicable to the single index single properties. You cannot have the query where you are applying inequality filters onto two properties. So this is one of the major restrictions we have. There's a very close relationship with sorting and the inequality filters, because every filtering or sorting is implemented as an index scan. So it means if you want to do any sorting, you have to prepare everything sorted beforehand as an index table. One of the famous restrictions for any NoSQL database is that join is not supported. Whenever a mission-critical system gets so big, denormalization issues occur. If you're splitting this database into multiple instances, you cannot execute join operations anymore. So if you're querying like this, where you'd want to join two different tables, like a person and address, you may want to put the country property into a person, not normalize the table, denormalizing the table. This means there's a trade-off between the performance or scalability and the redundancy or cost of managing multiple duplicated values onto the kind or many kinds. There are some tweaks you can emulate the join operation in DataStore. Like this, if you have to handle end-to-end relationships. In this example, each entity called person has friends, and they have an end-to-end relationship between person. In a traditional relational database, you'd have a join table called friends table, which represents every relationship between the single person. In DataStore, you don't have to have another join table to do that. You can just have a multi-valued property like this. Friends property may have a list of strings, list of the people names, so that they can write the query like this. If you want to find a mutual friend who is a friend for Bob and also a friend for Willie, then you can write a query like this. Select from person where friends equal Bob and friend equals to Willie, and location equals to San Francisco, for example. This query can be executed by using a single property index. You don't have to prepare a composite index for this query because the data store will be merging and joining the result from the two different queries into one. This means that you can implement the end-to-end relationship within the data store result without any join operation. You can still do this for joining between the same entities, in this case, person. This example is joining two different result sets for the same entities, but it's still a major restriction that you cannot join the different tables. There's another restriction. We have a workaround for the App Engine data store. In data store, you cannot execute any group by operations or aggregate functions. More specifically, you cannot execute counts from table, so you cannot count the number of entities you have right now. To be scalable, you don't have time to look at all the entities and count them all. You do have a workaround, having a special entity that maintains aggregates by you, like a counter entity, which holds the number of entities you've created. If you're doing this, however, you have to be careful about the entity's bottleneck. There are limitations like the one entity can only get one update per second. This is not a physical limit, but it's kind of a design property you have to follow. Because of this restriction, you cannot simply have one counter entity to count many accesses from the users. There's a design element called a sharding counter, where you are sharding the counters into multiple entities and gather aggregated results later. You can alternatively use memcache as a holder for that count value, and use DataStore as well to back up the latest count number. It's hard to implement a counter or any aggregate function on the data store. If it's not required to get the aggregated value instantly, then you can do it later by using batch processing, by using a backend instance. There's also a very useful open source framework called App Engine MapReduce, which is using TaskQ to emulate the MapReduce framework. We won't discuss details about the App Engine MapReduce, but this can efficiently handle batch operations on huge amounts of entities on DataStore. Finally, if it's not urgent, then you can just rely on the statistics API of the DataStore. DataStore provides statistics data like how many entries you have or what kind. By accessing the API for that, and those numbers will be updated once per day, so it's a very large number, but still, you can use that for certain usages. Moving on to the aggregation function restrictions, you cannot use the minimum function or maximum function like you have in your relational database. You may want to have a single property and sort it ascending or descending so that you can find the first entity on the index to get the minimum value or maximum value. This technique in DataStore allows you to have an aggregated value, like a count or average, or a maximum, while the order of log n speed, by using a data structure called skip list. Skip list is very similar to a binary or B tree. Just like a tree search, you don't have to look for every single node to find a node. You can start finding it from the express lane. The trick is, you can just add the aggregate values on each express lane to get the aggregated value on the data store. Using this data structure, you can obtain the average or a maximum or minimum values of a range of entries in a very short time period. You don't have to scan all the entities in the range. For example, how many entities do you have from the node 1 to node 6? Using the level 3 express lane, you find 3, and then you add 2, so that the answer will be 5. There are 5 nodes between node 1 and node 6. An important thing to consider is the cost of indexing in data store. This is a real application which has an entity with only 25 megabytes. However, it consumes a total of 238 megabytes somehow. The rest of the space is taken up by the indexes because that entity has so many single property index tables for each property. It means you need to have 10 times larger index space than the entity itself. This is another big difference between the data store and a traditional database. If you want to cost estimate data store accurately, then you have to think about the cost of index in terms of space. You may also want to check your document called Understanding Write Cost, which explains the CPU cost you consume for building the index. For every single entity write or update, it will also update the single property index or custom index you have created. When you are using hundreds of index tables, that means updates can take a very long time. And now to discuss some final caveats. There are no aggregation functions like the lower or upper or any other functions. You may want to pre-process or pre-calculate the value, putting an additional property on the entities so that you can implement it. Because DataStore doesn't support search, there's a very useful new API called Search API, which supports full text search. It converts every query into the index scan or key, so it means you cannot be applying the irregular expressions full text search on the index scan. So instead of using DataStore, we may recommend you look into the Search API for full text search. When you're using the query, you may not see that result instantly, returning the old data instead. To avoid this, you should use Ancestor Query. Ancestor Query guarantees strong consistency. It means you're always getting the latest result of your updates. And lastly, there's a combinational explosion phenomenon that can happen on large value properties. If you're having a multiple large value properties on the query or index, because multiple large value properties on the index, there will be a 10 times 10 log of combinations of the index. So you need to be careful when you're using the multiple large valued properties on your query or index. Let's now describe how transactions can work in DataStore. Now you understand how DataStore can be scalable with its unique practice like DataScan. It's time now to understand the transactional aspects in DataStore. In DataStore, you design
Hi, welcome back after this video. So there were a lot of concepts related to querying and indexing in this section, and that is what we will be also studying in our practical in activities and things like that. So yesterday we saw that this is a data store. This data store is used so that it is scalable. How is it made scalable? By sharding. That is, there is a copy of the data which is made if there are too many requests which are coming for writing onto it or for reading from it, and our database is not able to support it. So if you have multiple copies of data floating around, that puts in a lot of restrictions, and that's how the queries are done a bit differently than normal how it is done in SQL. So there are certain workarounds and certain restrictions. For example, one of the restrictions which was mentioned was that you cannot have a count of values which are there in the table. Anybody can tell me why you cannot have a count of values which are there in a table, like aggregate functions count? The second, okay, just think about this. Second is the indexes are used to, like the whenever you're querying, there is an index which is required, and only then you are able to query the data and on basis of indexes and not on the values. So whenever you have to do a query, that particular field should be indexed. In normal RDBMS, it is not required to be indexed. Only for purpose of increasing the speed, it is required. So there are a couple of functions which we will be studying, how we can query the data. This is not going to be SQL statement select star from table name for doing the query, or if there is something, let's say select star from table where age is greater than 25, or where name is equal to Ram. So all these select queries we already have learned in our SQL. They are implemented differently on data store. So we will see how they are implemented now. Okay. So we did this. This is done. Now we are looking at how do data store works. How does data store work on query? So that is the topic, queries. So as you're just listening, there is a table. Whenever you want to do a query, you have to have an index of that particular value, and only in that index there is a range scan, meaning that it checks sequentially in that index and then gets the data. And the efficiency of the query is how much data you are fetching. Like if you fetch large amount of data, your query will be slow. If you fetch less amount of data, your query will be faster. So data store queries are used to retrieve entries from the app engine data store after the specified conditions are met. Data store queries work on entities of a given kind. So we all remember yesterday's discussion on new terminology over here. I'm just trying to locate the terminology slide. So, small recap. So we had a data store. Data store has got kind, entity, property, and key. In RDBMS, its kind corresponds to a table, entity corresponds to row, and property is a column, and key is a primary key. So kindly keep this in mind. Kind is a table, entity is a row, property is column, key is primary key, or the key which is used to access the data. So so query works on entities of a given kind, and data store queries can specify filters on entities' property values, keys, and ancestors. Data store queries can return 0 or more entities as a result, and data store queries can contain following elements: an entity kind on which query will operate, filter based on which user needs to filter the records, and sort order in which user needs to sequence the results. So if you were to query, you will be filtering and sorting the data. So whatever column you are doing this query, there should be an index on it. And to do a query, there is a query class which is used to create a query and prepare query interface to retrieve entities from the data store. The query class encapsulates the request for 0 or more entities object from the data store. It allows you to raise queries on 0 or more properties given by ancestor or sorting data. The query class contains following constructors: query with ancestor. Now what is this ancestor? Query with key ancestor. What is this ancestor I'm talking about? Okay, so it's something like your you have a master table and you have a transaction table. In case of RDBMS, think of it like that. So you have two related tables. So in case of data store, what we do is, with the or even in RDBMS, what we do is we put a key in the transaction table of the master table. So you can think of master table as the ancestor of the transaction table. That means the records which are related with the transaction table from the key which is there in the master table, we can do that kind of a query using the ancestor key. But the overhead is that you have to store the ancestor key along with the data in the child table. So the terminology is slightly different here. So query class provides the following methods: get kind, get app ID, get namespace, add sort. This is the sort order, like you want to do ascending, descending. Get the ancestor key. This key will be used to check for the relationship. Query set ancestor key, and you can even filter data based on some conditions. So this class query will have a lot of functions or methods which we will see in one of the activities. And once the query is completed, the results are coming back. The result of the query is the prepared query interface contains methods to fetch and return entities, that is the rows, from the query. By default, order of the entities, that is the rows, are undefined. However, if the query specifies a sort order, entities are returned in specified order. The prepared query interface does not cache results. So the result is just transitory, and you have to, it's only in the data store it is saved. So it includes following methods, iterable, so that you can use the for loop to go through each of the result which is coming and display it or process it, and as list to process the result which is coming. So filters are used to set constraints on the properties, keys and ancestors for the entities to be retrieved. That is, the rows you want to retrieve, you can set the constraints on the properties, that is columns, the keys and the ancestor keys or ancestors. The filter class of the Google App Engine API data store query package is used to apply filter. The filter predicate class is used to create an instance of the filter class. The property filter specifies a property name, a comparison operator and a property value. So this is how it is used. So create a filter property object, new filter predicate, copyright year is the first parameter, which is the property name, the column in which you want to apply this filter, copyright year, and filter operator dot greater than or equal. This is how, it's not a simple SQL that you just give greater than equal to. You have to give filter operator dot greater than or equal 1939. Then you create a query object and you set a filter in this query object. So, and then you execute this query and get the result and then display the result. So it's a different set of commands than simple select star from table where something is there. Then there can be composite filter, meaning there can be two values on which, or two conditions which you want to apply together. So the composite filter class is used to set more than one filter on the query. The composite filter operator enum is also used to set more than one filter or query. The following code illustrates how to use composite filter operator. So if there is two filters objects like filter 1 F1, which is checking height is less than minimum age, and there is a filter 2 which is checking height is greater than maximum age, and you want to apply both the filter together, you can say composite filter F1 or F2. Composite filter operator dot or F1 or F2. So following table has the filter operators which we can use: equal, less than or equal, greater than or equal, not equal to, or in. So special property name entity.key reserve property is used to apply filter on values of the entity's key. The following code illustrates how to use filter on the value of an entity's key. So if you have a key called employee ID, so it's got create key function which you are using to create a key called my key, and in filter you're creating a key filter object which is new predicate, filter predicate, entity.key reserve property, filter.operator greater than my key. So you're checking for the key in this filter and applying this to the query queue. So whatever you're passing, you're checking, you have some employee ID you want to filter on. So that you passing to this key object. So let's say I have a key employee ID E001. in the employee table. So first I will have to make a key of it. I cannot search for a value E001. It will not work. I have to make a key of the employee code E001 and then set it as a filter to get that particular value. So similar to the query which is for a key filter, data store queries can apply a filter to a specified ancestor. Ancestor is like your master table in the normal traditional SQL, or your parent table. Here in case it's called as a parent table. The following code illustrates how to apply a filter to the specified ancestor. Here we are creating a small query object, then making a key. This Tom is the parent in the employee table, and then saying query.set ancestor that p key. So it will search for key. Tom will have a key, let's say E001, and then that is being converted to a primary key or key which you want to search in the child tables. So when we do the practical, you will get to understand this. And you can also sort the data, but you cannot say order by or something. You have to do it like this. Sorting data helps you to quickly visualize and understand data. A query sort order specifies the following elements: a property name, a sort order direction. So again, I make an object of query, new query employee, and we have a sort first name in the ascending. So sort direction is ascending, and over here this is wrong. The semicolon should be not there. Dot add sort salary sort direction descending. So this will sort in the descending order. If multiple sort orders are specified in the query, they are applied in the order in which they are specified. In the sense, you want to first apply on the first name and then on the salary. So it is applying two sorts, first on the first name column and second on the salary column. Here first name is in the ascending order and the salary is being sorted in the descending order. So let's look at one example and try to understand this, how the filters and sorting can work. So we will use another method of storing data using low-level Java data store APIs. What we'll do is we'll create this table called employee with title, salary, and employee code 102, 99, 101, 100, and these values. So, and then we will display sorted result based on the salary of the employee in the descending order. And also we will restrict the records where employee ID is greater than 100. So employee ID is greater than 100 is 101 and 102. And sorting result on basis of salary in descending order. So will come 5,000 first and 4,000 afterwards, descending order of the salary. So that is the problem statement, and this is the output. Oh, descending order. So this is the output we will be getting the query results of the employee table. Let's see this and then see how this is done, and then understand this. Okay, in the morning also I was mentioning there is a data file for student also, which has got exercises. So whatever data files are required for exercises are present here, and to the solved solution for exercises are also present here in the data files for faculty. That chapter. Okay, so this is the code which we have to run to understand the filtering part. So let's first understand the code and then we will deploy it. Okay. So in this code, first of all, I have a lot of imports. Here there is a Google App Engine, data store, query, filter, store service, data store, entity, prepared, query, query filter, sort direction. All these are import statements. And then we are writing this servlet. This data store service, get data store service, will also, it's a low level API which helps us to write data to the Google data store. In this, what we do is create a new entity, employee. We set its property to whatever the column names we want to put, employee ID, title, salary. And when we say ds.put, this record is inserted into the Google data store. This is the simplest method of putting the record into Google data store. Similarly, second record, third record, and fourth record. So all these records are added so that my table is created. I've got employee ID 101, 4,000 salary, 100, 3,000 salary. Then I create a filter property object using this employee ID, query filter operator greater than 100. This is a filter I am applying. Filter operator greater than 100 is the filter I am defining on employee ID. And then I set this filter using this q.setFilter, this property filter. So this query, when I have defined over here q is equal to new query on employee table, I am setting this property of saying that where the employee ID is more than 100, this is the filter condition. Then I say add sort on employee ID first and on salary descending. So what it will do is it will first sort on employee ID and then sort on salary. So if two people had same salary, then if the records are there, then it will sort the salary in descending order between those employee IDs. So then what we do is we say prepared query PQ is equal to ds dot prepare query q. So that will help us execute that query and get the results. And once we get the results, we will put in a for loop is as iterable. That means if there are more than one result, there are more results to be checked. We get those results into variables. So result is a variable or a entity which has got property employee ID, title, salary. We put them into these variables and display them over here. So let's try to execute this web application. So new web application, project name, let's say this is activity 8.1 sorting, filtering. Some package, and I will use 31 SDK and use app ID. Either I can create one or I can use the existing one. So I will use the existing one. I can go ahead and create one also. Any questions till now? We are just about to implement this. Any questions in your mind? You don't have SQL statements now. You have query class. Let me deploy this. I hope this works. Anyways, let me run this. On my local system. Oh, the name of this has changed the name. Servlet name. Servlet. Hopefully it should work now. Yeah, you may get this message. Somebody was already getting this. Port 88 is appearing used. Do you still want to continue this launch? So what I think has happened is that previous launch is already running. And I need to stop it. But where is my window which is there? Yeah, in the console, this is running in the background. Okay, so you have to click on this red button to stop this from running, and then you can run this again. Did you get this debugging step? This is again, I'm sure you may face a problem when you're doing this. What happened? Given me. Servlet. Maybe this is something to do with the paths. Does it disappear? Okay, there's something to do with my naming. Yes. Okay, let me do this again. I'll delete this. And I'll take some help. Maybe I'm missing a step. Okay. So I'm also making some mistakes. So let me follow the steps. New. Just change this to 31. Change this app ID. Okay, let's hope this time the names are fine. Okay, now let me try to see if it is already running. No. Save this. Not filter servlet. Yeah. Okay. Sort. Oh, it's so arty. But this will not work. Sort. Filter. Spelling mistake. Sorry. Thank you, Maninder. Okay, let's see now if it works. It's already in use in some background. So another debugging thing. No, it's already in use, so you have to stop this. Okay, this one we had documented. I think this error is there if this port is already in use. What to do? So let me see whether I can find this now. So in the end, we have tried to put in if this happens, what to do, I think. You open debug perspective by turning window open perspective debug. One second. Window open perspective debug. And then this, you can see a lot of things in the background are running. And this have to be stopped. So how do we terminate this? Okay, this is stopped. Yeah. So now they are stopped. Yeah. Great. Okay, so right now you're looking at the live demo of debugging which is happening. Like port 88 is already in use. So here you have to go to debug. Something may be running in the background. This is into Windows open perspective debug is what you have to do, and then you have to come back to your normal view. Where is my window? Okay, thank God it's come now. Only one result? What happened now? Okay. This is funny. This is again another funny thing which is happening. So we save all these results and do this, apply this filter and the sort order. But somehow I have to reset this data store. Whenever I run it, actually it will insert the record again. And unfortunately, somehow first time it has not registered the second record. but first time when I run it, actually it's supposed to be putting 2 records. So we'll put this now on the app engine. Stop this. Run as or Google deploy to app engine. So once you run locally, there was a very important debugging exercise which you just saw. So you have to terminate the processes which are running in the background. Where do you want me to click, Anjali? Here, maybe, yeah. Java, yeah. Okay. This is the debug window and this is the Java perspective. So in the debug, things are running in the background, then you have to stop it. So now this is done on the app engine. This also you have to see, there is an error which has come immediately. Because as soon as I deployed, I ran it. Right now indexes are not made. Let's see if I can show you the status of the backend. In my data store, there is an employee table. It has indexes, it has tables, but it is preparing. Look at the status preparing. You see this preparing? Employee ID, salary. It is showing preparing. Watch carefully. This is important. So whenever you run it, and immediately if you run it, you will get this kind of error, server error. Please try again in 30 seconds, because in 30 seconds or more, this index has to be serving, and then only this query will work, or filter and sorting will work. Otherwise, this is an error. So let me refresh this. Hopefully, it is done. Still preparing. So let me just run it again. Still error. So once this below are the composite index for the application. These indexes managed by your app's index configuration. So till the time the server creates this index, this query will not work. This is also another debugging thing. If you get this error, don't get panicked that your application is not running. Give it some time. So the status has to change from preparing to serving. Did you understand this? Just click on plus or minus if you understood this. Plus or minus. Yeah, good. So right now I'm waiting for time to make this indexing to be serving. Till it happens, this, even though it's running on my local system, I could see it's working on my local host, and I've deployed it over here. Over here the data is also present. I can show you data store. Employee, there are by the way, as many times I run it, it will add the record. So you'll have duplicates. So 1, 2, 3, 4, 5. 9, 10, 11, 12. So I run it 3 times, so it has got 12 records. That is because I ran that thing 3 times and I did not wait for that index to be created, and it will be some time. After some time, yeah, you can see now serving has come. Okay, so now serving has come. Great. So now serving has come. So now let me run this again, and now you can see that the query is working. Only thing is my code is written in such a way that first it inserts the record and then it displays it. But good part is that it is fetching employees greater than 100. Then the sort order, there are 2 sort orders. There is a sort order for employee and a sort order for salary. Let me comment this part out. Sort order for employee ID. And let's just do sorting on currently. Let's just sort it on salary. Now let's deploy this again. Let me first check if there is any impact on this. Maybe it's only composite index. Now let me run this. Again, some kind of index it is making. So for every kind of query, it has to have an index. Currently, it is automatically making indexes. For example, over here, if you look at this file, maybe that doesn't work also. Maybe it says data store indexes use one time in query history. So it's making an index of employee ID in ascending and in salary in descending in this auto generated index. So we just saw this kind of interaction where we could see data getting filtered and sorted on the local system. Then we deployed it onto the web server, and there we could see. Also, you can see over here a note. if you directly deploy to App Engine, you'll get an error and the web page may not get displayed because this is not configured. Okay. Another thing, another important thing. It may happen that my data index doesn't get created now because I've directly deployed this on my App Engine without deploying it locally first. Because when I deploy it locally, then it creates indexes and then it synchronizes in the App Engine. So what it's saying over here, this important note over here is, okay, there are two notes actually. As the data store uses eventual consistency, it is possible that data that is inserted in the data store is not immediately available. Therefore, you may not get all inserted records. That's what happened in the first case. I inserted 2 records, but only one came because there is a data store uses eventual consistency. That means it may not have inserted both the records immediately. It will probably sync it later on. It is possible that the data is inserted in data store is not immediately available. Therefore, you may not get all inserted records immediately. Therefore, display output may be different than the shown picture because in the first time I just had one record because of the way the data store works, the insert works. Then there is another important note that if I don't do the local install, it may be that my data store indexes file doesn't get created. This is my data store index file. Let me see if this is working now. Okay, let me deploy it locally first and then upload it. Run as web application. The first sort property must be the same as the property to which inequality filter is applied. So another rule violation. That is why the first property must be the same as the property to which inequality filter is applied. Inequality filter is applied on the employee ID. So let me leave employee ID and comment this and make this as sort direction descending. Let's try this. Float is in use, then you terminate this and you go back. So I'm getting descending order of employee ID now, right? This is descending order. You understand? Descending order has changed. It's coming 2002 earlier, 102, 102, and then 101. And now let me deploy this on the web server. So this has got couple of peculiarities, the filtering and the sorting. Okay, so here it is coming again, descending order of whatever the records are there. So the way that, I mean, my program is written that every time I run it, it adds one more time this thing. But anyways, this is just to show the descending order of employee ID. Is this clear, the sorting and the filtering? Is this clear, this example? Can you please click yes or no? Please click yes or no. Thank you. So we are looking again at slides. So this is the kind of output we got. And important, this note is also important. If you are running this application, then you must run this on your local server first and then deploy it onto the web, because there is something to do with the indexes which are created locally. The definitions are defined and then they get mapped onto the web server. Right now we are not explicitly defining indexes. In the next chapter we'll see how to explicitly define indexes. Right now indexes are getting created automatically by the app engine. They are creating indexes. And I can actually go and show you something more also. Okay, so it's serving right now, and data store and data store statistics. So there are some statistics available of data store which tells how much of entities, how much of data you are using. And it is saying last updated 1 day ago. Probably yesterday something was added to the data store. It may not be immediately updated. And it has got some built-in indexes of so many bytes. So this is going to give you a how much of data storage you are using. This is important because you will be probably paying for it in case you use too much of it. So data storage will also include space for indexes. So as if you have many indexes, so you will have more space utilization, and so your cost may go up. So you have to be careful in terms of selecting which fields you want to index or query on. Okay. So this was a little example of indexing, filtering and sorting. Now this same thing can be done using Objectify also. For doing that, we have Offie.load method of Objectify instance to use to load entities from Google Data Store. Now how do we do filtering and sorting in this Objectify? I think that is what is mentioned over here in this. Now here, which we have already seen, I think, but anyways, so here first of all, let's say I have a user ID E001. So first, I mean, currently it's picking up from the system, but supposing there was a user ID E001. So first of all, I have to create a key of it. Assuming profile was a class which we had created earlier, which was having the this thing, we have added the records in it. So user ID, we use it to create the key first and then pass that key over here to retrieve only that particular entity. And the following code illustrates how all entries in the particular kind can be accessed. So here we are not giving, in this query, we are retrieving all the values. We have already done it when we are using the retrieve function. And when we were doing for a specific value, that means update or delete, we were extracting a specific value and then that value was getting displayed. So we were doing this using Objectify, using this. Querying entities using Objectify is used using these functions that we have already seen. So now here we get to more complex queries. So supposing there are two conditions to be given. The following figure depicts query by kind and filter by property. So query by the kind means primary key. We are query by the primary key, and filter by property, that means trainer and Java. So the following code, so in case of Objectify, first we load this profile class, and this is showing how we can do this in Objectify. So we say dot filter, and profession is equal to, profession is the name of the column, trainer, and dot filter technology is equal to Java. So this actually makes it more simpler than running it through the way we have done right now. And then we say query dot list to get the list of values back. And this is querying and filtering using Objectify we are learning. Again, sorting data using Objectify, you can sort the result by saying order over here. You remember in our APIs we have been giving Offie.load type profile.class .order profile ID, and then we run this query.list. So this is when we are going to use the we will implement this shortly. And then there is something called as kindless queries that do not contain any kind or ancestor filter in it. These queries retrieve all entries of an application for the data store. These queries cannot include filter or sort order on property values. These queries can filter on entity keys by specifying key reserved property as the property name. So the following code illustrates how to filter on entity keys by specifying entity key reserved property. When you say key, my key, and you say employee ID is made as a key, and then you say new file predicate entity.key reserve property, comma, file operator greater than my key. So this is doing a query using the key which has been created earlier. Then you pass it to the query object. Over here, set filter to the query object, and this is the example of how to run a kindless query. There is also something called as ancestor queries. This is a query that contains ancestor filter and is known as ancestor query. Now what does this ancestor query do? I'll explain it with this example. So the ancestor filter within an ancestor query limits its result to the specified entity and its descendants. The following code illustrates how to use ancestor query. Okay, now just understand this. First of all, we say get data store, and Tom is a new entity with the name person, and Tom has its key. So when we are storing Tom will have a key, or Tom will be, so this value which is there for Tom will have a key, and this we are storing it in the database. When we say data store.put Tom, then when we say contact 1 is equal to new entity contact number Tom key, set property mobile number is 88988669. So what we are doing is it's like saying Tom has got a key, let's say for reference, should have put a diagram here. Okay, supposing over here Tom okay, till here there is one entity called Tom. Then over here there is another entity called contact number. It's like saying I am storing the name of the person in one table called person table, and or a person is one entity, and contact number is another entity. And when we are saving the contact number, we are also saying that this contact number belongs to Tom by using this Tom key. So that at the time of creation, this Tom key will be taken from here and stored along with the contact number over here when we are saying put contact number. So when we actually doing a query for getting the contact number of Tom, we will say query contact Q is equal to new query contact number dot set ancestor Tom key. So we are getting who the contact number for the Tom key. The similar use of ancestor query can be done using Objectify also, but that is not clear here. There is some code which has gone below this. Okay, that's just a running of the query. Okay, I'll come back to this later. So, okay, there is also kindless ancestor queries. Kindless ancestor queries include ancestor filter but does not contain any kind. That is the primary key. It retrieves the specified ancestor and all the descendants regardless of the kind and does not require custom indexes. It cannot include filters or sort orders or property values but can filter on the entity's key. So over here, let's say there is an employee with the employee ID and we say a new filter is defined over here. Here we have not specified anything. It says key reserve property. We have not specified any key over here. And filter operator is greater than my key. So when we run this query Q and we say q.set ancestor key, it will get all the values from the ancestor table. So we'll just see this with an example, it will become more clear. There are some key-only queries which return just the key of the result entities. It reduces the consumption of data store CPU time quota, and it also helps in reducing consumption of data store data received from API quota. The following code illustrates how to use key-only queries. When you say query Q new query employee dot set key only, so it will query only it will return only the key of the entity. So let's try to run this and see how the ancestor queries are being handled in Google App Engine. So you have been assigned a task to create a web page using low-level Java API which you need to implement concept of ancestor queries. With this example, we'll try to understand this ancestor queries. The web page should be based on the following guidelines. Sub-entities names, contact number and email address needs to be created for the parent entity named Tom of the person kind. Web page will display property values using ancestor query. And this is the expected output. So main entity name is Tom and its contact numbers are 2 phone numbers and it has got 2 email IDs. So let's run this and see if we are able to get this kind of output. Okay, so I will create a new application. And give com.examples here. Uncheck this, use 31. Use the app ID. I'm using the same app ID which I am and click finish. What happened? You're not seeing this? Okay. So I just now created a new project, web application project. In this we will be using the ancestor query concept. In that, let's look at the code first. So there will be a lot of imports related to the APIs which we are using. First of all, the query filter, entity, these are all part of your data store API of Google App Engine. And also there is this key. This is again a reserved key, is a reserved word here, so don't use it as your own word. So here we define a data store service and we create an entity called person which has Tom, and we get its key, let's assume its primary key over here, Tom key. Then next what we do is we create a contact number. Contact number is first number, this is second number, but using the same Tom key which is there. And so along with the number, we are also storing Tom key. This is creating a relationship between person and contact number. So there is a person and there is a contact number. Actually there are two contact numbers. And similarly there are two email addresses which belong to Tom. One is some Hotmail and one is Yahoo. So it's like one table connecting to two tables over here. One is the person table and the other are contact number and the email address. Next what we do is put these values as an array list and store it in the data store using this put function. Then we prepare a query. Result set 1 will get the values for the phone number and result 2 will get the values for the email address. So we just display that first of all we are getting the values of contact number and this is where we have defined the query. Contact query, new query, contact number, set ancestor as Tom key. So wherever there is a Tom key present with the phone number, those results will be stored in results variable when this value is returned as a list. Similarly, when we run this particular query, we will get the email addresses from the email which are already stored, and with using the while loop we will display this. So till there are some more records to be displayed, if iterator has next, we will check whether there is some value to be displayed. So we will display mobile number comma something, mobile number comma something. This is else is, do you want to put a comma or not? If this is a only one value and there is nothing after that, so comma will not be put. Similarly, email IDs are going to be retrieved, and till there are more email IDs to be displayed, it is going to run it. So let me just take these values from here. List query. Spelling problem. Okay, so it has displayed some values. Let's see in the back end what is there. This doesn't seem to getting updated. Okay, let me run it on data store. So similar to what questions we have done, there are exercises for students to practice. So here again there are some questions to sort and filter based on book ID. So you can see there is something called as contact number. There is something called as email address, and there is person. Person should be Tom. Yeah, person has got name, which is Tom. Then there is another, which is email address. It's like your related tables which you put in case of SQL. Email address and contact number. Currently there kind means table. Different tables are being stored. The values of this is being stored along with the ID of Tom. So person is the ancestor of contact number and email address in this case. Let's look at this code again. So when I said contact query, new query, contact number, set ancestor Tom key, what it is doing is that whatever contact numbers that belong to Tom will be returned. And similarly over here when I say email address, set ancestor Tom key, whatever email addresses that belong to Tom will be returned in this email query, and we get these results from this data store prepare email query as list, and in a while loop we display the values for the email address and the phone number. So let's break for 5 minutes and then come back for the next topic. Okay? So let's just break for 5 minutes.